And we are right on the clock. Well then, okay, let's begin. Hello everyone, and welcome to the Debugging React Native Apps End-to-End AMA with Sentry, Meta and Expo. So this is going to be a really fun AMA to me personally, and I sure hope so that you're gonna have fun as well. So yeah, let's kick things off by introducing the AMA team. I'm gonna start. I'm Nicola. I'm a DevRel here at Sentry, and I'm gonna be your host today. And let's move on to Nicola. Hi, Nico.
Hi, everyone. Super excited to be here. My name is Nicola Corti. I work in the React Native core team here in London. My background is mostly Android. And well, since I asked it in the chat, my favorite programming language is Kotlin. And I'll pass it over to Alex Hunt.
Thanks, Nico. Hi, I'm Alex Hunt. I work in the React Native Developer Experience team in London alongside Nico. My background is kind of front end, moving to infra now. I've been working on Metro, and presently I'm working on React Native debugging.
Hey everyone, my name is Cedric. I'm also super happy to be here. I work at Expo as a software consultant. I mostly work on partner support, community support, all the way to some Snack things, to SDK stuff. But lately I've been a lot involved in CLI work to power the new debugging tools in Expo.
Hey everyone, I'm Krystof, excited to be here talking about the languages. I love TypeScript and I'm happy to see many of the comments also mentioning it. And I work at Sentry on the Sentry React Native SDK.
Really cool. This is a seriously good lineup, not gonna lie. All right, so first we're gonna talk about why we picked debugging as the topic of this AMA. Then we're going to proceed answering the questions you left on the event registrations form, and there were plenty of them. And then we're gonna see some really cool demos from Krystof and Cedric. And of course, at the end, we're gonna answer all your questions, or we'll try to answer all your questions you come up with during this AMA. So again, yeah, feel free to use the Q&A feature here in Zoom at any point, and we'll get to them at the end. Yeah, that's all. Let's begin. So why are we focusing on debugging in today's AMA? Well, we consistently hear from React Native developers that they want better debugging and profiling experiences. That came up in the State of React Native survey, which is a survey of the 2,000 React Native developers run by Software Mention. Also, the team at Meta talked about debugging in their 2022 "How can we improve React Native" GitHub discussions, and they did receive a lot of upvotes. And also, our friends at Expo released the SDK 49 that focuses on debugging experience, like for example, the integrated network debugging feature, and also the VS Code Expo tools extensions. As you can see, there's a decent amount of focus and noise on debugging into the community, into the React Native community. So yeah, we decided to partner with our friends at Meta and Expo and talk about it. And let's dive in with the questions that you asked us from the registration form. First, we have what's coming. There we go. What's coming in React Native version 0.7 and 3, and this one goes to Alex.
Great. Yes. So 73, definitely some exciting features for debugging. Again, this is a top priority for our team. So yeah, first, the timeline for 73 is that we're iterating on features for the next month and a half. If all goes well, we'll release about mid-October. Timelines can change. So in this timeline, I think a headlining thing from debugging is we are deprecating Flipper. So it's a deprecation. In 73, Flipper can still be connected to new projects, but in React Native 74, or by the end of the year, we're going to no longer include the integration code for Flipper in new React Native projects by default. Flipper will still be available as an independent app for native debugging that you can connect and configure for an iOS or Android app, but the kind of first-class React Native support for it will no longer be there. This really let us push forward with our new debugging vision and like simplify the maintenance of React Native currently. Replacing that, we're going to change the default actions in the dev menu to introduce one-click flows for debugging to replace Flipper. So currently that's not a great experience when you've just installed React Native and you don't have the Flipper desktop app installed. You hit open debugger and it doesn't really even give you an error message when Flipper fails to open. We're going to fix this. It'll be a one-click flow that opens the JavaScript developer tools. And this is similar to what Expo does today. We're kind of energized and aligned with what they're doing around Chrome DevTools as the plugin host. And we're going to similarly have a one-click button to open React DevTools in a separate and standalone window. In terms of features for debugging as well, we are partnering really closely with the Hermes team throughout the rest of the year. We're going to be integrating the new re-architected Hermes debugging server. From this, you can expect reliability improvements to debugging, and the Hermes team will also be able to build features a bit faster. It's kind of like, imagine it as the depth of coverage of features in the console or sources panel in Chrome, getting more fully featured. And a specific feature in 73 coming from this is a new feature to improve console statements. We're going to have Hermes queue these so that when you open the debugger and you've opened the debugger later than your app's been running, you'll now see console logs since the start of your application's lifetime. So really our philosophy there is to match what web does and give a nice experience that's familiar to web developers. We're also beginning the architectural structure starting point for like a React Native debugging server too. This will unify the story around connecting to a React Native app. And we're centering around this around the Chrome DevTools protocol. In future, this is a starting point for more capabilities. So it's a bit behind the hood, but it's something we're working on for the long term. We're also going to mark JSC remote debugging as deprecated. Unfortunately, this has been broken for some time. We're definitely not abandoning JSC as our runtime. And we hope to reintroduce JSC debugging under the new model. And this is for the kind of alternate remote JS debugging flow currently. This is related to the next thing. Probably the biggest visual thing we'll do, 73, is we're planning a once-over of React Native's debugging docs with more information on getting started, kind of what JS debugging features are available step by step, coverage of kind of what debugging modes are currently supported, and also some information about separate native debugging tools to support some capabilities offered by Flipper today. Yeah, and then there'll be more coming in 74, but that's what we've planned to do in the next 2 months of execution.
That sounds like a lot of work and a lot of feature. So I'm pretty excited about this new version. Thank you, Alex. Okay, so then next we have what happened with Flipper. And I'm gonna ask Nicola this time.
Awesome. I'm super excited to take this one. Yeah, so for people in the audience who are not familiar with Flipper, Flipper is basically a standalone app that allows you to debug a native Android and iOS app. And it's developed internally at Meta. Like developers that are working like on the Facebook app use it daily to debug what's going on. And yeah, like back in the day, we thought like, maybe we can integrate like Flipper into our React Native story and like make that the de facto tool for debugging React Native applications. The problem is that like, even if you look at the React Native website right now and you go on the debugging page, Flipper is never mentioned. Like we sort of started to integrate Flipper, but we never went like all in. And practically what we were doing, we were pre-installing Flipper for everyone, but we were not doing like an amazing job in explaining users how to use it properly. So imagine like every React Native app out there had all the components and the setup to actually start Flipper, but only a small fraction of our users were using it. The problem of Flipper is that whenever we configure it, it brings in a lot of like external dependencies and just makes the build a little bit more complicated. So yeah, we ask folks like, are you using Flipper? How do you like it? Like, is it fitting within your workflow or not? And a lot of users were like unfamiliar with the tool, never really liked it, were like, they were just like coming maybe from a web background, so like not experienced with that specific type of debugging, which is more typical of more like native heavy type of development. And so, yeah, basically we took this decision of removing the integration of Flipper on our default application. This is the point that I want to stress. It's not that we're like killing Flipper entirely. We know that there are people out there that are using Flipper today and they will still be able to use it. We will just not pre-install it for every application because we just like practically, if you look at the amount of lines of code that a new React Native app has, on Android and on iOS, half of the code on Android is Flipper setup. And if people are not using it, then why we're like installing that for everyone? So this is a move to be like more lean and offer you like an initial app which is smaller and offers you only the experience that we believe are the smoothest and where we took a lot of care. So as Alex said, we're gonna revamp a lot of the documentation. We're gonna like provide more simplified guides. And this flow that was always like half broken in a sense will be partially phased out. So yeah, that's the story with Flipper. I want to mention that if you're interested in learning a little bit more this story and the background behind it, we do have a repository called Discussion and Proposals. You will find it at github.com/React Native community/discussions and proposal, where there is an RFC that explains you like in with thorough details why we made this change. We asked the community, so it's not just that one day we woke up and we said like, oh, let's drop this. We don't want to maintain it anymore. No, we actually asked folks, and this turned out to be one of the like biggest friction points. So that's how we decided to address it.
Awesome. Thank you, Nico. Then we have, what do you think about CDP or Chrome DevTools protocol? And this one goes to Cedric.
I mean, the CDP protocol has been used by web developers for a very, very long time now, right? And it basically has all the features that a web developer needs to not only make a really good front end, but also make sure everything keeps running with the backend or with the profiler. So it seems like a logical next step, since we're basically trying to pull web development into native development with React Native, to also take that step for web, right? Pull in the Chrome DevTools protocol. And with that, like, we have access to such a versatile tool that has so many different features already built in that we don't need to maintain or recreate. As long as we support the underlying like structure that powers it, you can just use it. And it's also not just the Chrome DevTools itself. Like, as I said, the VS Code debugging tool, it works with the same protocol. So basically every tool that exists out there right now that works with basic web development or web debugging should also be able to work with native. And I think that's the right direction for us. But then again, like, the Chrome DevTools protocol is created for web. And we have some limitations on native that doesn't exist on web. For example, like storage space. We cannot like save all big API blobs from network requests into the phone storage, because that would overflow at some point. So we have some workarounds in place to make it kind of a smooth experience. But overall, I think it's a very, very good mature protocol that can help us tremendously.
Cool. Yeah, CDP is a really cool thing. Okay, thank you so much, Cedric. Next we got, how does Sentry help with debugging? And of course, this one goes to our very own Krystof.
Thanks. So majority of you viewers know what Sentry does, right? We are collecting as much as useful information when error happens in production in your release app somewhere in the wild, and sometimes something can be missing. And question that we got multiple times was, I see a JavaScript error and I see it's coming from a native module, but I don't know where from the native module. And what am I supposed to do with this error? So we talked to the React Native team about this, and together came up with a solution of mixed stack traces to combine what happened in the JavaScript, what happened in the native module, and surface it to you as a user. So you know exactly what's the core issue, what's the core problem. And yeah, so this is what Sentry is helping with in React Native.
Awesome. Thank you, Krystof. And I saved the best for last. Can you share tips for debugging? And I don't want to point this to anyone, so this one goes to all of you. So let's work our way backwards. So we can do Krystof, Cedric, Nico, and Alex.
Okay, had a bit of trouble unmuting myself. My recommendation would be for every one of you who are updating dependencies, changing the React Native version, working with the native code, create a simple command, something like yarn clean iOS, yarn clean Android. It will save you so much headache and trouble when you're running into some build issues and you're trying to remember, oh, I need to delete the build folder, I need to clean the build, all these things. Like if you will just create the one command, it's such a time saver. Yeah, that's my tip.
I would say the best tip I can give is whenever you're trying to reproduce an issue reported by any of your users, try to stick as close as the environment in what it was reported. Any change in like the test environment can affect your app or test results. Like back in the day when we used to move the whole JavaScript engine to the browser, that was like such a dramatic difference that it's not really good in terms of debugging. But now that we can actually run it on your phone and connect directly to your phone, you should be able to get way closer to the actual environment that it was that the app issue occurs.
I can go next. So my first tip, I was talking with other folks before. Whenever you are debugging something, make sure first try to reboot and make sure that you rebooted your machine, just in case. No, I'm joking, obviously. So I'm a big fan of over customizing my IDE, and like basically our IDE is our toolbox. And like either if you use VS Code or if you use like I'm a big fan of the tools from JetBrains, so like WebStorm or IntelliJ. Those are like super feature heavy. Like literally the amount of things that are like available in those IDEs are like tremendous. And specifically for Android Studio as a great built-in mixed debugger that will allow you to attach two debugger, one on the JVM and one on the native side. So you will be able to put breakpoints on Java and on C++, which maybe not like, again, when we do React Native, we don't expect people to write neither Java nor C++, but sometimes if you do libraries, if you do more advanced stuff, you will have to deal with that code. Or if you have like a crazy bug and you want to put breakpoints inside the core of React Native, you might want to have that advanced tools to fully debug and understand what's going on. So my tip is like invest time in learning your IDE, because you should not use console log anymore. Like literally, like if you're using console log, go question yourself, because literally you're probably wasting so much time. And there are like a lot of tools that will let you like work better with your code base and your like runtime to understand what actually is happening.
Great, yeah. My recommendation is use Hermes. It provides the best JavaScript debugging experience currently, and it's the one we're investing in for like our best-in-class debugging workflow as we go forward. Again, like both the React Native and Hermes teams are really investing actively in making the experience better. And yeah, you can use for the best experience today as well, you can use the debugging.js on Hermes workflow using DevTools, which is documented in our docs under Hermes. This is the flow that's becoming default in 73.
Hey, these were some really good debugging tips. I should have written them down though. Yeah, luckily it's going to be recorded, so I can review the footage later. Okay, cool. So these were the questions that got repeatedly asked on the event registration form. Again, I'd like to remind you again, if you have any questions, please submit them using the Q&A feature here in Zoom. And coming up next, we have demo time. We'll get to see a couple of very cool demos that Cedric and Krystof prepared for us. Cedric, take it away.
Awesome. Can I share my screen?
Yep, go for it.
There we go. All right. So we talked a lot about the Chrome DevTools protocol, but how does it actually look, right? So in here, we have a super simple demo app. I'm just going to start it while I'm talking. There we go. I already built it from source, so it should pop up fairly soon. So in here, we have a fairly simple test app. We have a button on the first button basically just triggers an API call to the Art Institute of Chicago, I believe, their API, and then pulls some data and then renders it. But the other button is actually causing an exception. So let's see how that looks. So in here, we can see that Lockbox has some information about for us. But what if these exceptions are not really known where they come from? Like right here, it's pretty easy to spot, right? But what if they're obfuscated or like outside of the React tree? So let's pop up the Chrome DevTools and try to debug it. So I just press J in the terminal. If you use Expo, that's the key to start the DevTools. Then we're in a console. We can go to sources and even like inspect all the code that is being bundled in right now and execute it. So let's start with the hypothesis that we have no idea where the exception is coming from. So we just will pause the execution with this button on any exceptions. But since React is also catching these exceptions with Lockbox, we also need to enable pause on caught exceptions. Now, if I go back to my phone, I can just trigger it, and it will literally pause on the exact moment where the exception is being thrown. So in here, we can see that on our button press event handler, we can see that the turbo crash module get data crash is causing an exception. Now, this is useful to know, but we can't really inspect like this state the component is in right now. So I have no idea what data is. I have no idea what the other variables could be. So for that, we can do two things. One is just basically start typing in the console to execute small snippet of code. For example, over here, I'm just loading this variable and it will just pop up. You can even literally just execute other parts, other small snippet. But there's also another way, and that's actually using breakpoints. So let me stop this and just reload the whole app and debugging experience just to be sure. So we already established that the exception is being thrown on this line. So if I add a breakpoint over here, we can basically pause the app just before we're gonna throw the exception or trigger the exception. So I'm gonna press it. It says paused on breakpoint, and it has not been, like, it's not erroring yet. But this gives us access to the scope and some other really nice features. So we can just click through the whole code base and see where exactly the whole chain is going through. But we can also just inspect the variable scope. So over here, you can see that data is null. And if you had a really quick eye, you can also just hover over it and it will just say, hey, that's null. Now, this is great, but you have to constantly move between like multiple screens, right? I have my VS Code, I have the emulator or simulator, and I have DevTools running right here. whenever I edit anything here, I can't really save it either, since it's not attached to our actual code on the device. So wouldn't it be cool if we can just debug while we're coding? So let me just do that as well. So if you have the Expo Tools extension, there we go, this one. No, not this one, this one. If you have this one installed, you should be able to run a single command to connect to your device right away. And if you don't have any device connected, it will guide you through it. The command itself is just debug Expo app on a device or simulator using Hermes. And it is especially important to recognize that your app is using Hermes, since this only works with Hermes. Once I run that, I'm actually connected to my phone right away. Now in here, I can add a single breakpoint on the exact same line of code that basically triggers the error. And there we go. In here, we have pretty much the same information that I just showed you. But something we can do here is actually fix it right away, or like avoid the crash. So let's say type of is function or whatever, then we just run it. And if I continue the app, dismiss, and there we go, we just avoid it. This is all cool, since it's much closer to actually debugging, developing and debugging at the same time within one workflow. It's much more natural to actually use it like this. But it's not the only thing that we can show you in the debugging workflow. So going back to the app, I showed you everything around to crash on native, but I didn't show you the load data. And for that, we're going to open the DevTools again. Instead of sources, we're going to go straight to the network tab. And here's where things get interesting, because, oh, live demo. Let me just restart the app. Always the live demo gods. There we go. If we go straight to the network tab and execute any API call, we can actually see what kind of request our app is making. And not just that, we can actually go into the request, check the status, check the response, and even like go through the data. Now, this is fairly cool, since you can easily spot like failing API calls or API calls that take a super long time to load. But it's not just limited to API calls. If we were to re-render this whole page, including this image above, it will actually show you the image that it's downloading. So in this case, we can see the full like response, we can see a preview of the actual asset, but we can also see if it's optimized. So in this case, if we go back to the image itself, we can see that this is a very large image. It's like roughly 3,300 pixels by 1,600 pixels, which is large for how it's rendered here. But larger means like sharper images, so that's great. And since it's a WebP and just 154 KB, that's actually pretty good. But if you have other assets that are like 8 MB and unoptimized, you should be able to see the size right away. You should recognize it in the time as well. So this is useful in a lot of different ways. But yeah, so taking a step back, this all works locally. And if you were to work on your app and you get a user report, we cannot really connect the DevTools to the user that can be anywhere on the world. So maybe Krystof can tell us a bit more how we can manage that.
Thanks, Cedric. Yeah, exactly. Sometimes it happens that you don't catch the error in your development environment. You think all is good, release the app, send it to thousands of your users, and still something goes wrong. And that's what I'm going to show you now. Just to select my screen to share. All right. So you release the app. hopefully you installed Sentry to be able to capture all the errors that are happening out in the world. Just a quick recap. What I'm going to show now is available in the React Native nightly builds for now. Hopefully in the future, it will be in the release version and you all will be able to use it. So I've took the same app as Cedric was demoing. I've updated React Native to the nightly build. I've installed Sentry with this simple command that sets up everything on the native layers in the JavaScript, plays a code snippet to initialize the SDK. And to switch things up, I'm running here the Android emulator, and I've built the release build of the app. You can see the app on the side. It's the same exact app with the same exact crash on native button. But since we are in release, when I click the crash button, it's gone. The app crashed, and that's what your users are experiencing. And okay, so you can see that the button and the code is very suggestive where we should look for the error. Let's just review it once more. We see here the turbo crash module kind of indicates it will be some sort of module, maybe turbo module. So maybe we'll have to look in the native code. I don't know yet. We'll see, right? Let's take a look how the error looks right now. So now you should see the Sentry page with the error report. You see that the crash happened on Android. You see that it was on the press of the button. You see some basic information, and you see the stack trace with the code view. This is possible because during build of the release app, we upload the source map. So when Sentry receives the error, we can actually look up and show you the part of the code where the error happened. So you have more context right in the one view. We can scroll down, there are breadcrumbs, just small like things that can help you identify what was going on in the app, and more information. What's interesting here is this part about React Native, where in case you have multiple apps, multiple releases, you can quickly peek into what version of React Native this app was using, all sorts of stuff. But as you can see, this stack trace ends in JavaScript. And as I mentioned in the beginning, that's maybe not the end. We go back here again. Let's take a look what the turbo crash module actually is. I'll switch here to the Kotlin code, and you see the same get data crash method that accepts the query and calls a crash function that causes the runtime exception. Of course, this is like super simple example, but it's on purpose. We want it to be super easy to understand and super easy to show. I bet you can imagine that in a real life, you install the library that uses some native code. You haven't touched Kotlin code, nothing. It just failed, and you have no idea what did you wrong. And that can be very frustrating when you only see part of the stack. So now what's new? What's now in the nightly builds? Well, crash again. App is gone. And let's take a look how the stack trace looks now. So similar page, but right off the bat, you can see it's not anymore saying on press of a button, JavaScript error. We right away see runtime exception. Same information, it's the Android crash. We scroll a bit more down. Now there is more things in the stack trace. If I start from the bottom, we again see the turbo crash module, the JavaScript stack trace, and at the top we see it crashed in native. Last time we haven't seen where in the native, but we focus a bit more up here, here we see the JVM stack trace, and we see the get data crash on line 10 and crash function on line 15. Just to double check, if I go back to the code, yes, that's exactly where the function is. And this is super helpful. Either if you just developing using a library to be able to tell the developers of the library, this is where in the native code the crash happens, so they can actually help you investigate. Or if you yourself are developing a library that is using native code to see the whole stack trace, what was going on in JavaScript all the way down to Java or Objective-C or Swift in the case of iOS. That's amazing, and I hope you think so too. That was it for the demo. I hope you liked it. Let me stop sharing the screen. Okay.
All right, thank you for the demo. It was really cool. Okay, let me share the screen back so we can continue. Yeah, as I mentioned, really cool demos. Now we get to take some live questions. Ooh. You guys ready? All right, first one goes to Krystof. What's the best way to debug performance issues not confined to a specific component? For example, a Redux reducer.
Thanks. I would recommend using the profiler. We already seen in the Cedric demos the Chrome DevTools. One part of them lets you start profiling and actually see the flame chart where the most time in your code was spent, and I think that will likely help you to find what reducer, what function there was taking super long. If you kind of like looking for a place to start, yeah, that would be my recommendation.
Very cool, thank you, Krystof. Then we have a question for Nico. What is the alternative to Flipper?
Yeah, so this let me anticipate some of the things that Alex also mentioned. Like in the future, we're gonna basically recommend two family of tools for everything that is debugging on the, let's say, web layer, so JavaScript. You can use the tools like the Chrome DevTools that God just presented, and anything that is browser-like. So if you're coming from a web background, these tools that you already are familiar with, and they're like you just probably know how they work. So they will be easier for you to use. While if you want to debug things more natively, like on the Android and iOS layer, we're gonna publish some guidance with list of tools that you can use. For example, and this is from my personal experience, if you need to debug anything on the networking stack, you can use Charles proxy, which is like a proxy that you install on your machine, and you connect the device, like the emulator or the physical device, to that proxy, and that will basically check all the network, not just the one that React Native is initiating. Because like here we always talk about like simple app, like the one that we showed in the demo, but imagine like bigger applications that have like some surfaces on React Native, other surfaces that are like just native. They might have some surfaces in Flutter and so on. And debugging solutions which are like specific only to a framework will not let you have the bigger picture of what's going on the device. For that scenarios, you need more advanced tools that are specific to native debugging, like, as I said, network debuggers, or you can use, like, for example, the Android Studio C++ and Java debugger, which I mentioned before, that will let you debug the application end to end, and so on. So yeah, we will be working on like a list of recommendations, tools that we tried and we know sort of work with React Native, and they would be available on the website as links that you can like navigate to. And again, we will not try to re-explain how to use every tool. There are plenty of guides out there that explains you how to set up charts, for example. We will not have this is how you set up charts to debug your network page on the React Native website, just a collection of tools that we recommend to use. Alex, you want to add something on this?
Yeah, if I can add, and I guess the aim is we're not aiming to rebuild Flipper at all. Almost the way React Native is JavaScript logic communicating with a real native app and real native views. When you need to debug those real native views, we do recommend using the tools that come with those mature mobile frameworks. So Xcode Instruments, Android Studio. Yeah, we'd rather developers that need to get hands-on with those because it's going to go far deeper than any abstractions we can provide via custom tools. And yeah, especially when we're at a starting point where our debugging tooling is quite fragmented, missing some features, we really want to make that core JavaScript part of the debugging our focus in terms of the first party product we support. Yeah.
Awesome. Yeah, that makes a lot of sense. Thank you, guys. All right, next up, we have a question for Cedric. Is Expo tools coming for IntelliJ-based IDEs too?
So right now, we don't have any plans to also build extensions for other tooling. But, and that's why I wanted to answer this question, it shouldn't be too hard to actually build something yourself. And I'm really happy to chat with you or with anyone who asks, because there are multiple, to chat after the AMA to figure out exactly what you would need. Because what the VS Code extension does is basically reuse what's already there. And I'm pretty sure that WebStorm or like other IntelliJ editors have like node debugging built in already. And that should be kind of compatible with what we're proposing here. So yeah, I'm happy to chat. Hit me up on Twitter.
Thank you, Cedric. And the next one is for Krystof. When is the Sentry profiler coming to React Native?
So I already talked about profiling in my first question, or the question I was answering. And if you've been following the SDK repo, you might be able to guess the answer. And we are finishing this feature, and it will be coming in the upcoming days, where you will be able to try the first version of it. And we are very much looking forward for your feedback. And yeah, we are excited about it.
Awesome. Thank you, Krystof. Next up, we have one more for Nico. How would you direct a guy to go to the native side of development who is a JavaScript developer?
Okay, that's a great question. I would say if you are a JavaScript developer and you're familiar like with React Web, probably it's worth looking into creating an Android app with Jetpack Compose and creating an iOS app with Swift UI. Those native UI framework have a really similar paradigm to React itself. And like, obviously, I mean, name of functions will change and so on, and like different programming language will be harder. But I would say like start creating a simple app with that. And then by doing that, you will understand like how an Android app is built and what is an activity and so on. Then after you build a sample app, you will be able to get back to React Native and understand like they're exactly in between the two words. So you can do like everything in web, or you can do like more things in native. It really depends on you how much you want to share, like which layer of abstractions you want to develop your application. But yeah, I think that's really the beauty of React Native, that it's like it really sits in between, and it allows you like to use native. Like one thing that I like to repeat is like React Native is native. Like at the end of the day, we render buttons on screen, so you have all the freedom that Jetpack Compose also has.
Awesome. Thank you, Nico. And we have one more for Cedric. What options do we have connecting the code to the debugger if you're not using an Expo app?
So It's funny that I get this because I think Alex also can add some more on this one, but I do wanted to highlight that although we have built it into Expo right now, better support with the Hermes one-click debugging will be landing in future React Native versions, I believe as soon as 73 already. So it is coming right now. You have to set up the connection manually. You can still do that if you go to like the Chrome inspect tab and then add Metro as a point and then basically inspect the inspectable target. Full docs is available on the React Native docs, like reactnative.dev. But I do want to highlight that. Yes, that's possible.
Awesome. That is super cool. All right, next we got one more for Krystof. What can cause missing span instrumentation on certain transactions in Sentry? We're using the React Native Sentry integration with React Native React Navigation, but some of our screens show large values that seem to be inconsistent with our users' actual experience. Should we use custom transactions instead?
Thanks. When I saw the question, I would like to emphasize no, don't use custom instrumentation if you don't have to. And the second point I would like to show is Sentry with Profiler. Of course, from the question, I don't know if you are using this feature or not, but it's a great way to get more insight into what is happening in React into your transactions. You will see when the components were mounted, how long they were on the screen, and that can help to fill the gaps where you see missing instrumentation at the moment.
Okay, thank you, Krystof. Next one, we got one for Nico. What is the new architecture? With the new architecture, heavily using C++ in some major 3D party libraries, how can we ensure effective debugging of exceptions and distinguish between internal issues and actual production errors?
Okay, those are two questions in one. I will try to answer like being a little bit more generic, but if the person has specific requests, you can find me online as like github.com/cortinico. My email is there. You can find me an email. I'm happy to chat afterwards. But yeah, so new architecture. Yeah, I mean, you're right. The libraries can, if they want, include custom C++ code. Actually, there are benefits in doing that. Like you might want to have a module with a single implementation across multiple platforms, like Android, iOS, but also macOS and Windows. You just implement it once in C++ and you're done. Or you might also have like, crypto libraries that requires you to include another C++ library, or you want to do, I don't know, whatever you want. So the new architecture allows you this, but at the same time, people are afraid of it. Like I said, like, I don't want C++ code, and if my app crashes, what happens? We are aware of that. Like how to debug this and how to help developers. We are working effectively on two fronts. On one front is like we have a partnership with Sentry, which sort of helped us improve the quality of crash reporting. Like what Krystof showed you today was like a really simple example, but we could potentially extend that to go further down the stack. So in an ideal state, when the app crashes, if there is a relevant stack trace in C++, on the JVM on Java and on JavaScript, you could just report everything and show you like, hey, the app died and it was here, and here. So you know what's happening. So definitely the quality of the stack trace is one of our top priority for the new architecture, and we're investing on that. And then the other thing that I mentioned already is like, you can use the C++ debugger of Android Studio. Now I say like, yeah, use that. And actually last year you could not. Like we did a lot of work to make it possible. It's not really well documented, I have to mention, because it's new architecture, advanced stuff, and also it's work that we I think we shipped in 71. But effectively, if you have custom code, like even if you have library code that is C++ written, you could put a breakpoint there and click debug inside Android Studio, and execution will stop there, and you can inspect what's the C++ thing doing, similarly to how Cedric did for JavaScript. It's going to be C++, so it's not going to be as nice as TypeScript. That's the world we live in. But yeah, it's possible. We know that there are scenarios where that is a requirement, and we worked to sort of reorganize our artifacts and make sure that you can effectively debug C++ application, like C++ code, if you need to. Again, we don't expect every user to do so, but if you need to, we want to make sure that you can.
Awesome. Thank you. Thank you, Nicola. And let's do one more for you. What is your recommendations for teams using React Native version less than 72, for example, like 68? Is it worth investing the time to integrate Flipper or update to 72 and then get the latest debugging features?
This was also for me, no? Or yeah, it was for me. Okay.
Yeah.
Yeah. So upgrading. Also see like questions coming in the chat about upgrading, and I want to yeah, I want to give a couple of suggestions here. So if you are like writing a small to medium app and you're not using Expo, I want to know why at this point, because literally there is no like to my knowledge, there are no major blockers nowadays to use Expo, and they solve a lot of problem on the upgrade story. Like literally consider migrating to Expo. That might solve your upgrade problems if this is a thing for you. But let's say that, okay, you did your assessment. There is, I don't know, a use case that prevents you from using Expo. Okay, what do you do? My suggestion is like first to do incremental upgrades. Don't try to jump from 69 to 72 because that's most likely going to fail. Do 69, 70, then 70, 71, and so on. We do offer the upgrade helper, which should help you in like telling you how to upgrade your project. Make sure after every upgrade that everything works fine. There are other tools that can help you as well in upgrading. For example, there is a tool from Microsoft called RNX Kit, Line Depths, which will tell you if some of the libraries you are using are not compatible with the version of React Native. So that can also be helpful when you do those upgrades. In general, try to reduce the amount of third-party dependencies that you don't use. I saw some packages.json which were like, I don't know, 500 libraries. And I'm like, man, do you need all of them? Probably not. Like, just be a good citizen, try to clean them up. And for the Flipper thing, like the actual question that got asked, if you are on 69 and you're looking into upgrading to 72, I will focus on the upgrade. And then I will potentially wait for 73 and evaluate if the debugging capabilities that are offered by 73 are enough for you. If not, Flipper is still an option. But I would say I will not like invest on Flipper now to potentially remove it afterwards, especially because do not expect first-class support for Flipper from now on. That's the thing to be aware. So slowly, again, we will be removing the Flipper integration. We know that people use it, so there will still be bug, the things that we would potentially look into. We will update dependencies to sort of adhere to what Flipper requires, okay? But in the long run, Flipper support from the React Native team will slowly fade. So it's probably not a best bet if you're like deciding which tool to use nowadays, but if is the tool that your team wants to use, you can.
Awesome, that makes sense. Thank you, Nicola. And we have one last question. We have time for one last question. And that one goes to Cedric. Is the network inspector going to be able to log WebSockets too?
Unfortunately, not right now. The reason for that is we are actually tapping into the native layers of both iOS and Android to figure out what kind of requests are being sent. And note that it is only enabled in development and won't ever be in production, of course. But with that system, we basically can tap into simple requests like a GET request or post, boot, batch, delete, like any kinds of HTTP request. What we cannot do is tap into WebSocket yet. The reason for that is there is simply no like good native binding that we can tap into that allows us to like peek into what's going on there. There are other ways to implement it, like we can implement it on a JavaScript layer where we can send the data straight away to like over CDP to the debuggers. But that's something we postponed in order to get the base in a good shape and continue from there. So unfortunately, not yet.
Okay, thank you, Cedric. And I guess we're almost at the time. So I'd like to talk about Sentry just a little bit before we close this AMA. All right, so Sentry loves React Native, and apparently React Native loves Sentry back. Based on the latest State of React Native survey, 74% of developers use Sentry for crash reporting. That's pretty cool. 12,000 React Native apps that we all use on a daily basis also have Sentry installed. We also have 1.4 stars on our GitHub repository, so if you haven't already, give us a start. We also spoke with our friends at Relief, and this is what they had to say. So Relief is a mobile app that lets you track and share your biking, hiking, and running activities. They have 15 million happy users, and they keep them happy by ensuring that their app is stable and that it delivers the best user experience ever. So guess what? Sentry makes that easy for them. So yeah, if you want to learn more about what Sentry brings to your React Native app, head to our docs, docs.sentry.io/platform/react-native. Additionally, you can check out this pretty cool article, Tips for Optimizing React Native Application Performance, that we published on our blog. If you want to get involved into the discussions, feel free to join the Expo and Sentry Discord servers on the links that you can see on the screen, and also Sentry's, and also the GitHub discussions on the following links. If you have any more questions for us, feel free to join our Discord server at discord.gg/Sentry. And yeah, this is the end of this awesome AMA. I really hope that we answered most of your questions. First, I'd like to thank you for joining and for asking the questions. And also, I'd like to thank our panelists for taking the time to do this with us, for answering all the questions, and of course, for the awesome demos. Again, if you have a minute or two, please stick around and fill up the survey. We would definitely love to know what you think. Thank you everyone for joining in, and yeah, goodbye, take care.